Alright, this is a walkthrough of lab number 23. It's a lab on the photoelectric effect. And again, if you can't get the Java labs to work, I'm going to essentially do the lab, and it's up to you to record your observations. So what we're going to do is we're going to shine a light onto a metal. So here's my light, and here's my metal. And I first want you to make some predictions on what's going to happen if light strikes the metal surface at the lowest frequency, the highest frequency, and if we were to increase the intensity and while electrons are not being emitted, and then increase the intensity while electrons are being emitted. So what we can do is make your predictions, and we're going to go ahead and do that. So let me turn the light on, and lo and behold, electrons are being liberated because I'm shining ultraviolet on there. Lots of power. So I'm going to go to the lowest wavelength, the highest frequency. Now I'm going to go to the lowest frequency, the highest wavelength the simulation can do, and I'm going to increase the intensity all the way up. I'll decrease the intensity all the way down. I'll go to this scenario over here. Intensity is all the way down, and now I've turned intensity all the way up. So I didn't quite go in the order that it asked, but you should be able to make your observations from that. Now we're going to answer the same question. How does wavelength and intensity affect it? I know that's kind of redundant, but it's really kind of important. And we're going to now go and look at some factors that determines if electrons are ejected from a surface. It turns out that different metals are going to have different affinities to their electrons, and different energies are going to be required to strip electrons away from various metals. What we will do is we'll say the energy is going to be Planck's constant multiplied by the frequency, and we can determine the threshold frequency where electrons are no longer emitted from various surfaces. So a quick little pop over to the lab. We are on sodium, and I'll just put the intensity somewhere in the middle right here. And essentially I'm going to increase my wavelength, decrease my frequency, up until electrons are no longer emitted. You can kind of use the current thing right here. When the current reaches roughly 0 is going to be the threshold, although electrons still technically are emitted a little bit. It's just too small for this thing to measure. And I'm just going to say, well, okay, still seeing some electrons coming out. So it's probably around 502, maybe a little more, maybe 510. Definitely maybe 540 nanometers or so for sodium. Go ahead and convert that to the frequency. Now we can go ahead and take a look at zinc, copper, platinum, and calcium. So there's my zinc, and I'll go until I start seeing electrons, and I'll back off a little bit. So maybe around there, 293 nanometers. Let's go to copper. And it seems to be around, maybe 270 nanometers or so for copper. Copper really seems to like its electrons. Now we'll go to platinum. Platinum's probably around 200 nanometers, 202 nanometers or so. And lastly, we'll go to calcium. And they come shooting off of calcium, so probably in the ballpark of 444 nanometers or so. Now what we can do is we can mess around with the intensity. So we're going to select our favorite metal. I'll just leave it on calcium. And we're going to put the intensity of the light around 10%, making sure that we're above the threshold frequency, below the threshold wavelength, and see how the intensity affects the number of electrons. So I'll hop back to the lab. I'll make sure I'm ejecting electrons. I'll bring this down to 10% or so, and count the number of electrons coming off per second, and we'll jack this thing all the way up, and we can probably make an observation about that.